Hey there, awesome physics students. Now we want to talk about what is the connection between the velocity and the position time graph. Or if we have the position time graph, how do we get the velocity from that? Okay, so let's start with a simple physical example. Imagine you're in your car at a stoplight and it's red and then it turns green and you then push on the accelerator and you begin to accelerate away in the positive direction away from the stoplight. So in the very beginning, you're sitting there, and when you first press on the, let's go for, when I do this time interval, this motion diagram, let's go for time intervals of a half a second each. So during the first half second, you haven't moved very far because you're just beginning to accelerate. And then as you press on the accelerator, you begin to pick up speed. The distance you can cover in each half second increases. And so you can travel increasingly far. So 1, 2, 3, 4, 5. Yeah, that's what I want to do. Let's plot this. And the reason I wanted to do it vertically like this is because I wanted to plot this on a position time graph. So this is a one-dimensional situation. So we're just going to use our boring coordinate x to represent the position. We're going to start with position 0, and this is the time axis here. So if we start here, we have 1, 2, 3, 4, 5. So we have 5 other time intervals here. So let me go 1, 2, 3. I need to make these equal, 4, and 5. Okay. So during the first half a second, you are then found at this location, and then the next half second you've advanced a little bit further, and hopefully you can see what I'm doing here. I'm mapping the position across here. So then over this, at this point in time, you're going to be right there. And then at this point in time, you're going to be right there. Okay? So hopefully you can kind of see a trend from these data. If we join these points together with a line, you can see a nice curve that curves upwards. I didn't hit exactly all the points, but it's pretty good. So it's getting steeper. It's a curve that gets steeper as it goes along. Okay, so how would we get our velocity from this graph? So that's how we get a velocity time, a position time graph from the motion diagram. How do we get the velocity from this position time graph? Well, if you recall, the velocity is the displacement over the time interval. And so the displacement is how far have you advanced from each of these, over each of these points. So if we take this point and this point to be our 2 points of interest, the displacement is going to be the amount you've increased here. So that's the displacement. That's the rise of the graph between these 2 points. Okay? And then the time interval, that's along, of course, the horizontal axis here. That's going to be the amount of time that's elapsed since then. The delta t. So the delta t is the run, if you remember some of our common terminology that we used to use in grade school or middle school. So what we're really doing here is we're taking the rise, which is the vertical increase, divided by the run, which is the horizontal increase. Well, that is just the slope. Okay? And this is an important enough connection here that I want to write this out. The value of the velocity is the slope of the position time graph. Okay? We're going to use this over and over again here. The value of the velocity is the slope of the position time graph. Okay? You can see that the slope is the amount of steepness here. So here it's not very steep, and as you go on it gets steeper and steeper. And it's increasing, and so this one is positive. It's a positive slope. So what would some other slopes look like real quickly? Well, we talked about this one already. This one has a positive increasing slope. How would I get a negative velocity? Well, a negative velocity would be a negative slope, and so this one would have a negative slope. It's the rise in that case is negative because it's decreasing. it's getting closer to 0. So this is a negative velocity that is getting less steep, so that velocity is going towards 0. What would a 0 velocity look like? Well, and by the way, these are all position time graphs, just to be totally clear here. So what would a 0 velocity position time graph look like? Well, you would pick a spot, a position, and then you would stay in that position forever. So your position would be constant. And so a 0 velocity graph, position time graph, would look flat like this. That's 0 slope. Okay? So you can tell from your slope, either positive, negative, or 0 slope, what the velocity is. All right?